Hello, this is Professor Rios. In this occasion, we're going to do a review for the journeyman test um, so that you can, with confidence, pass that test. The first thing we need to do is to actually turn on the projector. Um, do you mind, please? It's only one, right? Yeah, thank you. In this section, we're going to do a review of, why is not coming on? Oh, yeah, it's there. A review of series circuits. A series circuit is a circuit in which a specified amount of current leaves a voltage source and flows through every electrical device in a single path before it returns to the voltage source. So it's the same current for all of them. This is an example of a series circuit. We have a power source, solar power source, going through those lamps. Okay, if we measure the current in any going by any of those lamps, we'll see that it's the same current. This is a typical setting of Christmas lights. In a series circuit, current is identical through all elements of the circuit. What are the practical uses of the series circuit? The lights. If any part of the series circuit is open, the current of the circuit will stop. A series circuit is not useful for lighting because if one lamp burns out, all the other lamps will go also, like in the case of the Christmas light. So let's say a filament breaks, every light turns off. So what is something practical about this? Control circuit. In a closed loop series, circuits are often used to control electrical equipment. A closed loop means that two wires series circuits are often used to control circuits. Okay, so you have the current going from L2. You're actually connecting L1 and L2 to that motor. Practical uses of series circuits. Signaling. Two-wire closed loops, circuits are often used to give a signal that something has occurred. For example, the signaling circuit arm are unready, okay? So if you open the any of the contacts in the windows, it will close the relay and the alarm will shut off. Actually, it will deactivate the relay, okay? And the contacts that are normally open um, will close and the alarm will go off. Another signaling circuit, um, this is the example when we open the door, the light and the horn turns on because the relay is deactivated. In this case, the internal wiring of an equipment, you have a 110 230 rated motor connected to a 230 voltage source. I must have the winding connected in series in order to each winding at least receive 110, 150 volts. In this case, the dual voltage single phase motor series is connected for 230 because the coils are connected together. The internal wiring of many types of equipment, such as motor winding, can be connected in series. Understanding series calculations. It is important to understand the relationship between current, voltage, and resistance and power in series circuit. We have done plenty of that. In this case, we have a power source or power supply, two resistors, and a load. So the power supplied by the source is equal to the power delivered to individual loads. Series calculation. Resistors in series are added, okay? The electromotive force provides the pressure to move the electrons through the circuit. The voltage drop for each resistor can be calculated by the formula E is equal I times R. Here we have the resistance and the formula for the total resistance. Series calculations. Kirchhoff voltage law. Kirchhoff voltage law states that in a series circuit, the sum of voltage drops across all of the resistors will equal the applied voltage. Here we have an example where the power source is the voltage of the power source is the same as the addition of all the voltage in the circuit. Series calculation. The power of the power supply is distributed among the circuit resistances according to a law of proportion. Okay. And here you have, depending on the resistance, you have more or less voltage, even though you have the same current. Kirchhoff current law states that in a node, the addition of all current is equal to zero, or is the same as saying the addition of the currents that go in is the same as the currents that are leaving the node. Here we have current law states that the sum of current flowing into a junction equals the sum of current leaving that junction. That's basically it. Here we have another circuit, and we can measure the voltages, and we'll see that the voltages is the same for depends on the current. But now the current is going to be the same for all of them. Power. The power consumed in a series circuit will be equal to the sum of the power consumed by all of the resistance in the series circuit. According to the formula, power is equal R times I squared. Series circuit and law of conservation of energy. An example. In this case, we determine like what is the power delivered by the battery and what is the power delivered to individual loads. Series circuit calculations. Determine the resistance of each resistive element in the circuit. If you know the nameplate E and P rating, you can determine the resistance by the formula R is equal E2 divided by P, which is the power. Series circuit calculation, more of the same. We have done plenty of this. Series circuit calculation, you add the resistors. Power calculation. Power calculation is equal to resistance times current to the square value, okay, or voltage times current. In series circuit, The power calculations are calculated the same way with the power formula. There are often many different ways to solve electrical circuit problems involving current, voltage, and resistance and power. Series circuit nodes. The total resistance is equal to the sum of all resistance. This is obvious. I know you all know this, but I just want to go through the whole thing. Current remains the same in series circuit. You all know that. VD is equal to the voltage of the source, that's by definition. And the total power is equal to the sum of the power delivered to the individual resistors. Series connected power supplies. When power supplies are connected in series, the voltage of the power supply will be an additive provided the polarities are connected properly. Okay. Yes. Series connected power supply. Here we have a 6-volt battery, feeding a lamp. Okay. Here we have series connected power supply with a delta-delta transformer. Series connected primary windings are those, and the series connected secondary ones are those. Okay. Parallel circuits. We know parallel circuits, but let's go through this real quick. A parallel circuit is a circuit where there are two or more paths on which the current may flow. A parallel circuit is one with several different paths through which the electric can travel, like a river. It is a drawing of parallel circuits. The branch 1 and branch 2 are in parallel, and the lights are connected in parallel to each other, and if any branch is opened, the power supply continues to provide voltage to the remaining part. That's the case of plugging actual light in the outlets. Now, when wiring multiple receptors on a circuit, they are connected in parallel with each other, in parallel. Okay. Practical uses of lighting in parallel. Example of light connected in parallel. Those lamps like that. Using lighting in the panel. Practical uses of parallel circuits. Other use. Parallel circuits are used for fire alarm circuits. If any initializing device closes, the signal circuit is completed and the alarm will close. In this case, parallel circuit, sample A, you have parallel circuit are also called open loop systems. Can be used for fire alarm, police stations, and different sensing or detecting devices. Practical use of the parallel circuits. Other electrical components with the appliances will have components connected to in parallel. That's the relay, that's the open circuit, the pulse 1 and pull station, and small detectors, okay? Usually when something like that happens, the switch closes on. In the case of the pull station, when you pull the cord, is actually when open the circuit and the alarm goes off. Now, are you aware of what a pull station is in a job? This place that has a little shower for emergency, it's called pull station because you actually pull something to make it work. External wiring equipment, parallel connected. Parallel connected, the dual voltage single phase motor is connected to 110 volt. Okay. The internal wiring of many types of equipment, such as motor winding, can be parallel connected, depending on the application. Understanding parallel calculations. Voltage in a parallel circuit, the voltage drop across the resistance is equal to the voltage supplied by the open source. The voltage drop across each resistance is equal to the source voltage. Voltage drop across each resistor is the same, okay? Now, let's understand parallel calculation. Kirchhoff current law states that the total current provided by the source to a parallel circuit will be equal to the sum of the current of all branches. The current can be calculated by formula I is equal to V over R. You have here parallel circuits connected. This is to realize that the currents are different depending on the resistors. You know the formulas already. These resistors in series, parallel combinations, that's basically what we are. Parallel circuits, you know the formulas to do the parallel circuits. Okay. Series circuits. And so on. Let's go to another more interesting slide. That's material you guys already covered. Uh, if I end the stream, will you stop?